Hello, my differential equation class student. This is, I think it's my last lecture for this semester. It will be a review for your final. I remember some of type of equation we maybe forgot because this was a while ago. Okay, first I'm talk about differential equation with separable variable. What does mean? You have first order differential equation dy over dx equal, and function what you have, you can easily write like product two function. One is function dependent variable x and one is function dependent variable y. This means something like this. This kind of equation we call differential equation with separable variable. What this will be here? It will be dy over gy equal fx times dx. And take it integral both side. Right for respect variable x and left respect variable y, you have some solution. Don't forget add c. Okay, for example, I have something like this. Dy over dx equal x minus 1 times y to the fifth order over x squared times 2y cubed minus y. Well, you can see it's easy separate, and you have 2y cubed minus y over y to the fifth dy equal x minus 1 over x squared dx. Here we a little bit simplify and solve. You have 2 over y squared minus 1 over y fourth dy equal 1 over x minus 1 over x squared dx. Take integral here is no problem. You have y is negative 2 the power, this means will be negative 1, this means minus 2 over y. Here is y is negative 4 power, it means be negative 3, this means plus 1 over 3 y to the third equal 1 over x, natural logarithm x, minus 1 over x squared, it will be plus 1 over x, and plus some c. Practically, we finish. We're solving our equation. Okay. One more type of equation when I ask you is linear equation, first order. Here we have this kind of example. For example, if you have y prime plus p x y equals some fx, then you found multiplicator rho x, it will be e exponent integral px dx. Okay, this is new type of equation, and multiplied your, after you counting, multiplied your equation for this row x, you have full differential is left part and some function depend only x in right part. Take it integral for both sides, you solving. For example, I have 2x y prime minus 3y equal 9x to the cube. First, we rewrite our equation as standard form. This means I need to divide my equation for 2x. And I have y prime minus 3 over 2x y equal 9/2 x to the square. Px here is 3 over negative 3 over 2x. This is my function px. This means root of the x multiplicator will be e to the power negative 3/2 3 over 2x dx. It will be e to the negative 3/2 natural log power. It will be x to the power negative 3/2. This means I need my equation 1 multiplied by x to the negative 3/2 power. What I have? X to the negative 3/2 power y prime minus 3/2. What is will be x? Negative 1, negative 3/2. It means negative 5/2 power y equal 9/2 x to the 1/2 power. Left part my equation is x to the negative 3/2 y. Take it derivative. If you remember how they derivative for product, it will be exactly what we have. And here we have 4/2 x to the 1/2. Take it integral for both sides. Left part is will be x negative 3/2 y. Right part is will be, okay guys, it's 9/2. So this is interesting for me how it's 9 move to 4. 9/2. Okay, 9/2 x to the new powers will be 3/2 divided by 3/2 plus some constant c. Okay, this means y will be, we need multiplied by x to the power 3/2 for found exactly y. It will be, here it will be 3x to the cube plus c x to the 3/2 power. This is your final answer for linear equation. Next type of equation what I'm ask you in the test, final test, is will be exact equation. This means equation how you can rewrite like shape m function depend for both of variable x and y dx plus n function who is depend both of variable x, y dy equals 0. Equation we call exact equation if you take it function m variable respect y, it will be same like you take it function n variable respect x. If this is equal, this means exit function who is first derivative, first differential, will be exactly your equation. Okay, and this means exists some function f xy such as f differential f, it will be m dx plus n dy. And we need found function f. I show in example how we're doing. Okay, first let's go, we have some example. X cubed plus y over x dx plus 2x squared y 4y cubed dy equals 0. Here we're checking this is exact equation or not. This part is will be m This part will be n. Try found m respect derivative respect y. Here we have y is only one part. This means this will be 1 over x. Okay. Try found n derivative respect x. Here you have 4xy. You see, this is not equal. This means this is not exact equation. This means no, and we can use our method. Okay, looking for one more equation. I'm specially show you because we have question whether it's exact equation or not. You need checking. Okay, let's go this kind of equation. You have 1 plus ye power xy dx plus 2y plus x to the e to the power xy dy equal 0. Okay. First, this will be function m. This function is n. Derivative m respect y will be, here you have 1 is 0, it's no problem. This we have product function, y and e exponent xy. This means e exponent xy plus y x e exponent xy. And derivative respect x, it's give me 2y's will be 0, and here we have product. This means e to the x to the y plus x y e to the x to the y. How you can see, this is equal function, this is equal. This means you have answer yes for question this is exact equation or not. And now we try solving. Okay, what will be f here? We take integral from some part of your function, part of your equation. It's 1 plus yex y dx and plus some part of function who is depend only y. Continue. What we have here? It will be x. Exponential function. Here we have only one place when you have variable. It will be only here, you see, because you integrate respect x. It will be like y e to the x power y. And because y here is coefficient, this means you divide by y. Plus some function depend only y. Here y and y cancel it. This means our function f is x plus e exponent xy plus part depend y. How we can found this part depend y? Question mark. We need found derivative f respect y. What this will be? For x it will be 0. For e exponent xy it will be x e exponent xy plus g prime for y. And here is need be equal your n function. What is n function? Go back. It's 2y plus x e exponent xy. 2y plus x e exponent xy. Simplify this equation. We have g prime for y equal exactly to y. This means g from y, it will be y squared, and our function f equal x plus e to the power xy plus y squared. And because derivative this function full differential equals 0, this means this is equal constant. Or equal C, how you want one write. We solve our equation. Oops. Now we talk little bit about homogeneous equation and non-homogeneous equation. Okay, first homogeneous equation. Let's go, we have some equation. Third derivative plus 10y second plus 25 first equal 0 with some initial point, with this mean y from 0 equal 3, y prime from 0 equal 4, and second derivative from 0 equal 5. Okay, great. First we write characteristic equation. How you remember, we found solution our homogeneous equation like exponential function, and this one we have r to the cube plus 10r squared plus 25r equals 0. R take out, you have r squared plus 10r plus 25 equals 0. And here you have r equals 0, and first r equals 0, and second r equal third one, and equal negative 5. I especially give you example what happened if it's both of your, if you have some same solution. Okay, this means your general solution is will be r equals 0, give you some constant, you don't know what, but it's C1. Because your second and third solution is equal, this means you have some C2 plus C3 times x, e exponent, and this value r is will be coefficient your exponential, minus 5 to the x. You see, this is general solution, but because you have some initial point, we found. If you plug in x equals 0, but before I think we found first and second derivative, it will be more simple when you for plugging. First derivative C1 is 0, this means here you have we use product rule, this means you have C3 e exponent minus 5x minus 5 times C2 plus C3x e exponent minus 5x. This is first derivative, and second derivative it will be minus 5 C3 e exponent minus 5x. This we have, if you take a derivative for first product, it will be minus 5 C3 minus 5 C3 e exponent minus 5x. This means same like we have here, and plus 25 C2 plus C3x e exponent minus 5x. Okay, believe me, I'm right here. So if we plug in our x equal 0, what we have for first value function, you have only C1 plus C2 equal 3. Plugging x equals 0 for first derivative, you have minus 5 C2 plus C3 equal 4. And plugging for second derivative, you have 25 C2 minus 10 C3 equal 5. Solve this system. I think it's no problem. For us we have C1 equal 24 over 5, C2 equal negative 9 over 5, and C3 equal negative 5. This means our solution will be 24 over 5 plus negative 9/5 minus 5x e to the negative 5x power. This is our final answer. Okay. See what happened if you have some homogeneous equation and not all root our characteristic equation is real number. This means you have some complex number there, and how you can find general solution. Okay, I give you this kind of equation. Okay, 6y to the fourth derivative plus 5y to the third derivative plus 25y to the second derivative plus 20y to the first plus 4y equals 0. Okay, and here we have one of solution. This means you have one solution. It will be cosine 2x. Okay. First write is our characteristic equation. Sorry, this is 3. Looks like I don't know what. Okay, here we have 6r to the fourth plus 5r to the third plus 25r squared plus 20r plus 4 equals 0. And because you have one of your solution is cosine 2x, this means r equal plus or minus 2i. Now it's your solution. This means you have factor r squared plus 4. Because r plus 2i, r minus 2i, if you distribute, give us r squared plus 4. This means my polynomial I can divide by r squared plus 4. Okay, all right, what we have here? We divide for this polynomial. It will be 6r cubed plus, oops, 6r fourths. What I write here of cube, I don't know. 5r cubed plus 25r squared plus 20r plus 4. Okay, this means the result will be here 6r fourths, r squared. This means 6r squared. This will be 6r fourths, and 4 times 6r squared, it will be 24r squared. And right when we have plus subtract, you have r squared there, but I have 5r cubed before. Okay, this means I have plus 5r. We remember how we did all the separation before. It will be 5r cubed plus 20r. Subtract, I have, oops, we have r square and plus 4. This means, oops, okay, it's a long writing. This means I have plus, oops, plus 1 there, and r squared plus 4, subtract, I have 0. What does mean? We have result our division. Our equation is will be r squared plus 4, one factor, and 6r squared plus 5r plus 1, it's second factor. Okay, great. Move. And this means here we have r equal plus minus 2i. Here we can factor in, it will be 3r plus 1, 2r plus 1. R equal negative 1/3. R equal negative 1/2. And this means general solution, our homogeneous equation is will be C1, C2, C3, C4, it's your order, what solution you have on first or second. Okay, for example, it will be C1 cosine 2x plus C2 sine 2x plus, okay, C3 e to the negative x over 3, because negative 1/3, and plus C4 e to the negative half of x. This is all your solution for this non-homogeneous equation, your general solution. Okay. Now we try solving non-homogeneous equation. This is, I give you two examples. Oops, what has happened? I cannot move. Okay, now. First, look, we have non-homogeneous equation with y to the fourth derivative minus 2y to the second plus y equal, let's go x squared. First, rewrite characteristic. First, we try found homogeneous equation. This means y to the fourth minus twice y to the second plus y equals 0. And write this characteristic equation. It will be r to the fourth minus 2r to the square plus 1 equals 0. Please give me r squared minus 1 square equal 0. Please give me r minus 1 square times r plus 1 square equals 0. This means here we have r first equal r second equal 1, and r third equal r fourth equal negative 1. You see, this means general solution, our homogeneous equation, homogeneous part, it will be C1 plus C2x e to the x plus c3 plus c4x e to the negative x. Great. But we need solving non-homogeneous equation. Looking for right part our equation, we have x squared. This means particular solution, it will be some polynomial second order. Because it's not, we don't have for r equal 0, it's not mean some corresponding part. Okay, we have because this is quadratic, x squared, this means we have some polynomial second degree. It will be ax squared plus bx plus c. We need found all derivative until fourth. Okay, first derivative give us 2ax plus b. Second derivative give us 2a. And third and fourth derivative, it will be 0. And all other derivative, highest order, it will be 0. Plugging in our equation, we have 0 minus twice second derivative, this means minus 4a, plus function, this means plus ax squared plus bx plus c equal x squared. Here we have a equal 1 because ax squared equal x squared. B equals 0 because right part you don't have anything. And c minus 4a equal 0. This means c equal 4. And your particular solution, it will be x squared plus 4. General solution here, it will be c1 plus c2 x e exponent x plus c3 plus c4 x e exponent minus x plus x squared plus 4. You see? What happened if you have situation whereas your general solution, when solution your homogeneous equation, some corresponding and some relation with function who stay in the right part. Doing one more example. Y second derivative plus y equal cosine x. Okay. Characteristic equation here is r squared plus 1 equals 0. This means r equal plus or minus I. But if you have plus or minus I, this means general solution homogeneous equation, it will be c1 cosine x plus c2 sine x. But looking here, cosine x is exactly same like you have in the right part your equation. This means we found particular solution, our particular solution with shape ax cosine x plus bx sine x. Oops, sine x. Use this fact because you remember, because it's some relation between solution is our homogeneous equation and right part our equation. Found derivative for plugging, what you have, use product rule, you have a cosine x minus ax sine x plus b sine x plus bx cosine x. Found second derivative. We have derivative a cosine x will be minus a sine x. Use product rule for second term. You give it minus a sine x. This means I can write twice here. And minus a x cosine x. Okay. B sine x give us derivative plus b cosine x. Use product rule for last terms. We have b cosine x. This means we can write twice here. And minus b x sine x. Okay. Plug what we found for our equation. When it's half second derivative, this means minus 2a sine x minus ax cosine x plus 2b cosine x minus bx sine x plus value plus function, this means plus y. It will be plus ax cosine x plus bx sine x equal cosine x. Okay. After simplifying, this means this is cancelled, and bx sine x cancelled. I have minus 2a sine x plus 2b cosine x equal cosine x. This means a equal 0 and 2b equal 1, b equal 1/2. Okay. And here we have our final general solution. We have y equal c1 cosine x plus c2 sine x plus 1/2 x sine x. See? General solution plus particular solution. It will be general solution homogeneous equation plus particular solution give us general solution non-homogeneous equation. Okay. And then we have some interesting theorem when we use solution, linear independent solution homogeneous equation and found particular solution. How you remember, we use Wronskian and some formula. Doing this example, for example, I have with this method for this example, y second plus 4y equal sine square x. And how you remember, this theorem works very well if you have second order differential equation and if you have any kind of function with your right part. Only question how you can integrate or not. Okay. Right characteristic equation, you have r squared plus 4 equals 0. This means r equal plus or minus 2i. And this is give you two linear independent solutions, cosine 2x and sine 2x. Okay, let's go y first. This will be cosine 2x. And y second, this will be sine 2x. Now I need counting my Wronskian. Wronskian will be some determinant what we have. First row, it will be your function, cosine 2x, sine 2x. You remember, order, it's your choice. But when you did this order, continue solving because it's depend Wronskian counting and depend how you in formula plugging. Here we did. Derivative cosine 2x is minus 2 sine 2x. Derivative sine 2x will be 2 cosine 2x. And count, you have 2 cosine square 2x. Subtract another diagonal, you have plus 2 sine square 2x. With all of them is equal to. This means we have two linear independent functions. We count Wronskian and we can plug in our formula. If you have your particular solution, it will be negative first function, this means negative cosine 2x, or opposite sign, integral, product your right part function in your equation, this means our sine square x, multiplied by second solution, this will be sine 2x, and divide by Wronskian dx, plus second part is will be here a switch, but only plus we have plus sine 2x integral, here we have sine square x times cosine 2x divided by 2 dx. Now we need only counts in this two integral. Okay, do it separately and see. Then we plug in. Okay, here we have integral from sine square x sine 2x over 2 dx. Here it will be easy way. Remember what is sine 2x, trigonometric identity. And here I have sine cube x cosine x dx. Use substitution with sine. Derivative sine is cosine. Give me sine fourth power x over 4. Okay. Second integral. We have sine square x cosine 2x over 2 dx. This is give me 1/4. Here I remember identity how moving from square to first order. It will be 1 minus cosine 2x dx. It's give me, if I distribute, it will be cosine 2x is great, but it's give me cosine square 2x. It's not great. This means I use same method, but 2x twice, it give me cosine 4x over 2, here's over 2 dx. And all of them will be 1/4. Integral from cosine, this will be sine. This means here I have 1/2 sine 2x. And then you have minus 1/2. Oops. And inside, integral from 1, it will be x. Integral from cosine 4x, it will be sine. This means plus 1/4 sine 4x. Okay, we found second integral too. I think I need to close one more parenthesis. And but just a moment, I have 1/2 and then 1/4. This means here I have 1/8. 1/8. All right. Okay. Now we are ready for plugging our particular solution. Okay. Our particular solution, it will be negative cosine 2x, negative cosine 2x multiplied by, oh, here we don't need parentheses, here we have only sine for power x over 4, and second is will be much longer, plus sine 2x, and here I need to write, okay, sine 2x over 4, I'll write this way, and I'll write sine 2x over 2 minus x over 2 minus sine 4x over 8. Okay guys, I'm especially not spend time for simplifying, because if you're solving this method this way, I think it's enough. Good. And second part, our exam, it will be something from Laplace transformation and question. I'm not give it serious, but maybe question will be found. This is point. What kind of point we have? This mean is ordinary or singular or regular, irregular, something like this. For Laplace transformation, oops, I try move. You see, sometimes it's not work very well. Okay, for Laplace transformation, I give you something like, for example, when you have something like this, when you have, oops, where I write S, tell me please, where you have initial point x from 0 equals 1, x prime from 0 equal -1, something like this. Or if you have some multiplied by some constant variable, sorry, and something like, just a moment, something like here, b, for example, when you have something like plus 3t minus 1 x prime plus 3x equals 0. If you have x from 0 equals 0. But I'm not show you now how it's solving, because you have you can see I'm show all this kind of example. I'm only show how hard your question will be in test. Okay, and for series, one more time, I'm not asking solving you series, but I'm asking about what kind of point you have, something like this. It's similar question 3 in your last quiz. Okay, good luck and see you in the final. Bye.